Welcome back to part 2 of proportional and non-proportional relationships and situations. Today we're going to distinguish between the proportional and non-proportional situations using a table. One thing to keep in mind is if there is not a constant rate of change in the data displayed in the table, then the table represents a nonlinear, non-proportional relationship. And remember that our constant is our y value divided by our x value, and if it's the same value each time. Cannot be linear if it doesn't have a constant. A linear relationship represented by a table is a proportional relationship when the quotient of each pair of numbers is constant. Otherwise, the linear relationship is non-proportional. So if it doesn't have a constant, it's not proportional. Let's take a look at example 3. The value in the table represent the number of US dollars 3 tourists trade for Mexican pesos. The relationship is linear. Is the relationship proportional or non-proportional? And so what they've done is they looked to see if there's a constant. So they took the number of pesos and divided it by the number of dollars, and when they did that, they get 13. If they divide the number of pesos by the number of dollars traded, they get 13. They divided the number of pesos received by the number of dollars traded, then they got 13. So there is a constant. Therefore, we know that it is linear. Now, they want to know, is it proportional or non-proportional? Well, one thing to think about is that if you have $0 to trade, how many pesos would you receive? Well, if you're saying 0, then you're correct. Because you have the ordered pair of 0, 0, this is telling me that if I were to graph this information in a graph, that it would pass through the origin because the ordered pair 0, 0 is the origin. So this is a proportional relationship. Let's take a look at the your turns. So on number 9, they want us to determine if the relationship represented by each table is proportional or non-proportional. And remember, one of the first thing we did was to look to see if there's a constant. So if I take 30 and divide it by 2, so 30 over 2, that's going to give us 15. If I take 90 over 8, 90 divided by 8 gives me 11.25. Well, already I can see I have no constant. Because I have no constant, is this proportional or non-proportional? It's going to be non-proportional. Okay, let's take a look at number 10. When I look at these, I see that I have 5 to 1, 40 to 8, and 65 to 13. And I know that my constant is my y over my x. So that would be 1 over 5. That can't simplify down anymore. This one would be 8 over 40. And that simplifies down by dividing both by 8. I get 1/5. And if I take 13 to 65, and I divide both by 13, I get 1/5. I do have a constant this time. And if I were to, I would say this is proportional. We can compare proportional and non-proportional situations. We can use what we have learned about proportional and non-proportional relationships to compare similar real-world situations that are given using different representations. And when they're talking about different representations, one may be given in a graph, one in a table, or maybe even an equation. And so let's take a look at example 4, part A. It says a laser tag league has a choice of 2 arenas for a tournament. In both cases, X is the number of hours and Y is the total charge. Compare and contrast these two situations. Well, when I look at arena A, and it's an equation, if I were to compare it to the slope-intercept form, do I have a y-intercept? No, there's no y-intercept. So, because my y-intercept is 0, this is proportional. In my arena B, when I take a look at this, remember, to be a proportional relationship, the line has to pass through what point? The origin. When I look at this one, it's passing through right here. Is this at the origin? No, it is not. So that means that this one is non-proportional. Okay? When I look at this one, I see that it looks like it's right at 50. And so that's telling me that I have an initial cost of $50 before I even do anything. So that's why it's going to be non-proportional. Okay? Let's take a look at part B. It says Jessica is remodeling and has a choice of 2 painters. In both cases, X is the number of hours and Y is the total charge. Compare and contrast these two situations. Well, when I look at painter A, I see that if I were to write it in the slope-intercept form, what would my y-intercept be? You're right, 0. And because it's at 0, then this is proportional. So what this means is that she's only going to have to pay $45 per hour. Okay? When I look at painter B, it's in a table. And I look at that, and the first thing I need to decide is it proportional or non-proportional? And I see this, I have an X of 0. And remember, the y-intercept, the X is always at 0. And then where it crosses the y-axis is going to be my initial start. And I see here I have 0 and 20. Because I have something besides a 0, 0, this is telling me that this is non-proportional. And that's because there's an initial cost of $20 before the painter starts charging for the per hour. If I were to try to find the difference in, or my rate of change, I would find that it's 35. And so that's telling me it's $35 per hour after the $20 fee. Okay? And so this is non-proportional. All right, so let's take a look at number 11 on my your turn. I have 2 test prep centers. I have test prep center A and test prep center B. And we're going to compare and contrast these two. It says the cost for test prep center A is given by C equals 20H, where C is the cost in dollars and H is the number of hours you attend. So just looking at this equation, is it proportional or non-proportional? If you're saying it's proportional, you're correct. And there is no initial cost. It's only $20 per hour. So it's $20 per hour to get assistance. Okay? All right, so, and this one's going to be B. Test Prep Center B charges $25 per hour to attend, but you have a $100 coupon that you can use to reduce the cost. So it's going to cost me $25 per hour. So if we're using the H for hours, and the total cost is going to be C, but you have a $100 coupon that you can use. And remember, do coupons add money or take money off? They take money away. So it's going to be minus 100. Now that I have my equation, is this proportional or non-proportional? There is a y-intercept of negative 100, so this is non-proportional. Okay? Let's take a look at the next. The tables represent linear relationships. Determine if the relationship is proportional or non-proportional. Okay? So the first thing we're going to do is we're going to find, see if there's a constant. So if I take 12, and remember a constant is y over x. So I'm going to take 12 over 3, and that simplifies to 4. 36 over 9, and that simplifies to 4. 84 over 21 simplifies to 4. I have a constant. Is it proportional or non-proportional? It is proportional. Take a look at number 6. Do I have a constant? My y is 4. My x is 22. I can simplify that to 2 over 11. This one would be 8 over 46. I can divide both by 2. That would give me 4 over 23. And this one would be 10 over 58. I can divide both by 2, and that gives me 5 over 29. Are these constant? No, because there is no constant, this is non-proportional. If you have any questions, please make sure you ask your teacher.